Hi everyone, welcome back to the channel. So today we are going to solve problem number 13, that is Roman to integer. Here we are given the table which shows translation from Roman numeral symbols to typical number. So the question here is we need to convert the given Roman to integer. We will be given a string of Roman numeral symbol and we want output in the integer value, which is basically the numerical translation of that string. For example, here we are given a string of Roman numeral symbol and output would be the numerical translation of that string using this table. So here we can see for symbol I the value is 1 and here we can see there are 3 I. And basically they have added 1 plus 1 plus 1, but there is one subtraction case as well which we need to consider. So let me go over the steps on when we should consider adding and when we should consider subtracting. Okay, now let me take an example here. Suppose we have this as our numerical symbol which we need to convert to its integer translation. Okay, so now we will refer the table and check what's the value of symbol I. It's 1, and for symbol V the value is 5. Now let me independently write value of each symbol here. So it's 1 and y. Now here you can see I precedes its larger value 5. So in this case we subtract smaller number from larger number, which is 5 minus 1 equal 4. And this is the numerical translation of this symbol. So when a smaller number precedes a larger number, then we subtract. That's the only case we need to consider here, otherwise we add. Okay, now I will straight go into the algorithm and walk you through the steps. To solve this problem, we will begin by creating a map to store each Roman numeral symbol along with its corresponding integer value, with the symbol as the key and the integer as the value. So basically we are trying to store this table in the map, as map will allow us to easily access the value associated with each symbol during the conversion process. The idea behind the algorithm is to iterate through the input string of Roman numerals, comparing each symbol's value with the value of the next symbol. So if the current symbol has a greater value than the next symbol, we simply add its corresponding integer value to some variable called result, which we will return at the end of the function. However, if the current symbol has a lesser value than the next symbol, it indicates a subtraction case. In such cases, we subtract the current symbol's value from the next symbol's value and add the result to the overall integer value. So by performing this comparison iteratively, we effectively convert the entire Roman numeral string into its corresponding integer representation. Let me go over addition case and a subtraction case with you quickly. So we will maintain a result variable which is 0. Now the current symbol is I and the next symbol is j. We will compare its integer value which is 1 1, so it's equal. So we will add the value of the current symbol to the result and increment the point. Okay, but with the subtraction case, here is what happens. So let's take this for example. So I is pointing at the current symbol which is I, and J is pointing to the next symbol which is X. So we will take its numerical translation, which is 1 and 10. So here 1 is less than 10. In such scenario, what happens is we will subtract current symbol's value, which is 1, from the next symbol's value, which is 10, and add it to the result. And in this scenario, we will increment I and j both by 2, because we are done with comparing both the symbols here. Okay. In case of addition, we just increment I and j by 1, because we are just adding the current symbol's value to the result when it's greater than or equal to. So we don't skip the next symbol, we consider it as the current symbol in the next iteration. Now there is one more case which I want to consider, which is last symbol. So for each last symbol in the string, we directly add its value to the result, as there is no next pointer to compare that symbol with. Let me continue this addition example here to explain about it. So we have already compared 1 and 1 here in first iteration, and we saw it's equal. Then we added the value of current symbol, which is I, to the result, and then moved I and j pointer by 1. So now I is pointing to this symbol and j is pointing at this last symbol of the string. So we will take its integer value, which is 1, 1, compare them. Now they are equal, so we know what to do. We need to add the current symbol's value to the result. So we will add 1 plus 1, which becomes 2, and increment both I and j by 1. So now I is pointing at the last symbol and j is now out of bounds. So here there is no next pointer that I can compare with. So we'll directly add the value of I to the result. 2 plus 1, because value of I is 1 here, so it is 2 plus 1, 3. So this is one of the case, and it applies to both addition as well as subtraction case. And then finally we will return the result integer value as the output of the algorithm. Let me implement the algorithm now. Firstly, I initialize a hash map where the keys represent Roman numeral symbols, each being a character. And the corresponding values represent their integer equivalents. Next, I insert each symbol along with its respective integer value into the hash map. This process is repeated for all symbols which are shown here. Okay, so let me do that. Okay, so now we are done inserting all the symbols with its value in the hash map. Now let me convert the string into the character array for easy access. Now next step will be we need to initialize result, like to store the final integer value of the Roman numeral string, which we will convert and return at the end of the function. At the start it will be 0. Here I will also initialize I and j as pointers to traverse the symbols array. I will point at index 0 at the start and j will point to the next symbol, that is 1. So this is like at the very start. Let me initialize while loop that continues until the pointer I reaches the end of the symbols array. So it will be while I is less than symbols dot length. Okay, now inside the loop I will first start with the subtraction case, where we first check the next symbol to which j is pointing at, it doesn't go out of bounds. And the next condition will be if the value of the symbol at position I is less than the value of the symbol at position j, then we subtract the value of the symbol at position I from the value at position j, and we will add that to the result variable. So let me first mention that check. Okay, for that we need to access our hash map to get the value. So Roman map dot get, and then we need to get the value at symbol I, and if it is less than the value at symbol j, then we do that subtraction. So let me directly add that to the result variable. Again we will use our hash map to get the value. And then we will increment I pointer by 2 and j pointer by 2. If this condition is false, then we know that it's an addition case, and we will simply add the value of symbol at position I to the result variable. And increment the pointers I and j by 1 to move to the next symbol pair. Okay. And at the end of the loop we will simply return the result variable. Let me run this and check. Oh, sorry, there was some typo here. Yeah, let me submit this. Okay, now let me go over the time complexity of this. So here the function Roman2int will take overall O of n as time complexity, where n is the length of the input string. This is because the function iterates through each character of the input string exactly once in a while loop. And the space complexity is also of n. This is because we are creating a character array with size equal to the length of the input string, which is s, and this will require O of n space. Additionally, also we are using hash map to store the Roman numeral to integer mappings, but the size of this hash map is constant and does not depend on the input size, so it does not contribute to the overall space complexity in terms of the input size. So the dominant factor is the character array symbols, resulting in this space complexity of O of n. And yeah, now let's take an example and walk through the code. This is our input string and we will convert it into first character array, and we have already initialized result variable here and our 2 pointers. Let's jump over the while loop and check for the condition. So I value here is 0 and our length of our array is 7. So this condition satisfies. Let us go over the if condition. So symbol I is pointing at M at the very start and symbol J is pointing to C. Let's compare their value. So value of M is 1000 and value of J is 100. So clearly I value at symbol I is greater than value at symbol J. So we'll jump over to the else case as this doesn't satisfy our condition, and here we will directly add to our result, or let us maintain the result here. Okay, so at the very start it's 0 plus. So what does the else condition say? We directly have to add the value at symbol I to the result, and then we have to increment I and j. So now what is the value of I and j? So now let us do this. We'll do I and j here. Okay, so I and j. So I will point at 1 and j will point at 2. Now let us compare the characters at 1 and 2. So C and M. Again we do the same drill. So what is the value at symbol C, which I is pointing at? It's 100, and J is pointing to symbol M, which is 1000. So 1000 is greater than 100, so it satisfies the if condition. Also J is not out of bounds, so we move ahead. So here what we do is we subtract lower value from the higher and add it to the result. So 1000 minus 100, that is 900, and we increment I and j by 2. because we have already done the subtraction which involved both the numbers. So we move to the next pair, you can say. Okay, so I is incremented by 2, so it's become 3 and this become 4. So now it's pointing as x and c. So now let us again do the same thing. What is the value at x? It's 10 and c it's 100. So 100 is greater than 10, so it satisfies the subtraction case. So we do the similar thing, we subtract and add it to the result. 100 minus 10 becomes 90. We add it to the result and we increment I and j by 2. So this becomes 5, this becomes 6. Sorry. Okay. So this is I and b. We again do the similar thing. Value at I is 1 and value at v is, and value of v is 5. So here again value to which symbol j is pointing at is greater than the value at which symbol I is pointing, so it satisfies the subtraction case. We again subtract and add it to the result. 5 minus 1 is 4. We add that to result and then we increment both the pointers by 2. But when we check while condition, we can see that 7 is not greater than 7 but it's equal to. So this breaks the while loop and we return a result which is 1994. Thank you.